want to say at the outset before I give my presentation that the research I'm going to talk about and the perspective I'm going to talk about comes from the work with several thousand collaborators. This is all team science. It involves people across the world, technologists of different stripes, engineers, other technical specialists. It involves medical doctors. It involves therapists with different approaches and backgrounds. And then, of course, beyond this, it involves an interaction with millions of individuals that have been subject to this training. So I just want you to know that I represent this group. I'm the unelected representative. And I want you to understand that all of this comes from us collectively, from all of us collectively, everyone in this large family of people has made a contribution. So I'm going to talk about your plastic brain, and I'm going to reiterate some things that have been said in the last two talks about it. I'm going to talk about how it contributes to creating you, and also to creating your world, as you understand the world, both an internal conception of yourself, which is just as important as an internal conception of the things outside, which you interpret as the world, the environment that you live in, that you're immersed in. I'm going to talk about how we've tried to use this science to drive brains in improving or corrective directions. I call it harnessing the genie, because as the science evolves, we increasingly understand how to drive it, to use it in an individual in need of help, or even in any individual, to drive improvements of performance, to drive people in potentially improving, strengthening directions so that they can grow again, so that they can thrive. It's all about growing you. And that's what my subject is all about in the end. So first of all, we now understand, and this has been talked about earlier, that there's a revolution in our understanding of what we are and how the abilities that are expressed in us, where they come from. They actually come from within us by change in our brain. Our brain is actually remodeling itself each time we acquire or refine a skill or ability. That remodeling, that revision of the brain, it's changing physically, it's changing functionally, it's changing chemically. And that revision actually accounts for the acquisition or the improvement of the ability. Each one of us, of course, comes into the world in a different place. Each one of us has individual experiences and in billions of moments. A brain change, about half of those moments you could say come from the outside. They come from the interaction with the world into which we just happen to have been born. An equally large number comes from inside, because the brain is just the plastic for the things that are occurring within us in our thoughts and in the mental operations in our brain, as are the operations on the things in the external environment. And because the environment is so richly varied, of course, it differentiates us one from another. No one identical. No one in this room has a brain. No one has a machine that's identical to any other. Every machine in every skull in this room, in fact, everywhere in the world, every brain that ever was or ever will be is different in detail from every other brain. It's a wonderful thing. It's a tremendous gift of the creator of the universe or Mother Nature, whoever else you want to assign the gift. Now, one of the things about this amazing process is that, of course, it's fundamental to the brain, and it's with us as long as we're here. So we know that a woman of this age, for example, can acquire an ability, a marvelous ability, or improve an ability at any point in life. And the fact that improvement can occur, the fact that ability can be acquired, means that her brain is still plastic, still alterable, still changeable for the better. And it's a hard aspect of our operations to kill. We may have great struggles in life. We may have limitations in life. But nonetheless, we retain this tremendous power, this intrinsic ability to change for the better, to improve, to be a little better at something tomorrow than we are at it today. No matter what our lot, whether we're banged on the head, or we have a childhood that leaves us in trouble, or we have genetic faults that leave us struggling, nonetheless, we have this power to drive change for the better. And basically, this is what I'm dedicated to, and this is what the scientists, the engineers, and medical doctors, and health professionals that I'm working with, that we work together on, are trying to do. We're trying to basically use this power, especially in individuals in need of help, to try to drive them into a better position in life. Now, I just want to say that it's all about neurological specialization. So if we look down at the brain of somebody that has acquired any special ability, you could imagine this wonderful young woman earlier playing the violin. That woman has developed a brain that has the machinery in the brain because of her extensive work on the violin, that you could call a violinist's brain. It wasn't there before she acquired that ability. It wasn't there before those many hundreds, thousands of hours of practice and effort. It actually develops in the brain, and we can see it if we image the brain. We can see that she has it. And I would say very few of us in the room, if anyone in this room, has it. You actually grow this machinery in the brain. Now, here's a very simple example of a young boy who's learned a skill. Most of you have learned it in this room. And as a consequence, he has a brain that we could call a reading brain. We can look down at his brain and image it in the act of reading. And as indicated by the green circles, which didn't appear, there they are, there are areas in the brain that we know to be critical for reading. If changes do not occur, if the system does not come in place, this brain can't read. The area that's towards the back of the brain that we see here is actually an area in which we know there is occurring the critical association between the sound parts of words that bear meaning in words and their representation by letter. And that translation has to be made at high speed with great facility, with great reliability. And when, in a brain that develops that skill or ability, we see this area is activated as a part of a complex system, that is the reading brain system. The area that's circled more anteriorly actually contributes to the representation of the meaning of words when those words are represented in written form. And if you don't know or you don't have the ability to interpret the meaning of words in written form, no activation occurs in this area. We know this in part because we can look at brains of non-readers, and we see that they lack this activity. They do not have a reading brain, either because their brain has not yet got to the point of acquiring this ability, or because no matter how much they struggle, they cannot acquire this ability. They left behind, in a sense, frustrated because of other limitations in their earlier brain's history. Now, it turns out it's relatively easy, and most people that can't read, with our understanding of the neurological processes that underlie reading, to drive the brain correctively. And in fact, it turns out in the contemporary way that we would approach this, it takes about 17 hours of practice, intensive practice, of an individual of a kid, to drive the brain so that for the great majority of children that can't read, we recover activity in the system, we cover the activation of the system in the brain that contributes to or accounts for reading. We again activate these critical areas. We again generate these critical activities. We grow the system in the brain, and guess what? The kid can read. Now, just one interesting thing about that 17 hours of training, it did not involve reading. And the reason that it did not involve reading, because in those 17 of 20 children that are represented by that experiment who reacquired the ability to read, their fundamental problem was not a problem that was visual in its nature. It was a problem with the listening accuracy, which did not devolve the sound parts of words in the normal, accurate way. So they were actually trained as accurate listeners. Or to put it another way, if you want to correct a problem that's expressed by the real complexity of real brain systems, it's not always self-evident how that correction has to be played out in the way you would re-engage that brain to drive the correction. We have to understand the complex neurology that underlies the abilities that are important to us to acquire or to reacquire in the case of a brain that's wounded or injured or dysfunctional or just losing it because we're getting a little older. Now, one last thing about that brain of a required leader, you might notice that below the circle is a sort of hotspot of activity. And that hotspot of activity occurs in normal brain, in the kid acquiring the ability to read, in the act of acquisition. If we looked at this brain 3 months later, as the kid initiates reading, real reading now, with the listening problem corrected, the brain will look just like the brain at the upper right. You can actually drive very complex corrections in most brains for many, many problems like this that have complex neurological underpinnings. Now, from another perspective, and I might say, you have driven your brain to be a specialist in skill after skill and ability after ability. And in a very real sense, that's what defines you operationally as the unique person that you are. Each one of us has a repertoire of skills and abilities that have driven these special operational characteristics in our brain. And if we could look down in it, if we could look on it, we'd see all of the evidence that you have put those things in place by the efforts and by the experiences of your earlier life. But while the brain has been doing this, you could say creating the operational you, it's been creating something else very interesting. It's been creating, in a sense, yourself. And it does this because it's making constant, it's actually constructing your reality. It's constructing your world by constructing the social relationships of things that go with one another within it. And that's the basis of creating a stable model of the things that are in front of me that I'm interacting with in the world. I'm actually building a forest, a myriad, hundreds of millions of associations of what goes with what, given the circumstances of the moment, what should be expected to come next. Now, every time the brain goes through any such operation, anytime you have a feeling, anytime you have a thought, anytime you perform an action, the brain makes another association. And the association is recorded by your brain plasticity. And that association is to the source of the thought or the feeling of the action. And the source is you. So through billions of moments of change, the brain actually creates a centered and reliable representation of you as the agent. You are the actor in the play. You are created in the brain as the person that's controlling its actions, that's feeling its feelings, that's controlling and generating its thoughts. And we actually know that the brain creates several of these constructs. It creates an area in the brain which is associating every contact on the surface of your horny hide that creates the embodied you. If you think of where you are or what you are, you realize that you come to the limits of your skin. On the other hand, if you think about where you are as an interpreter of things coming out from the world through your eyes, and you say, well, where am I? You locate yourself sort of in the center of your head, behind your eyes. In a series of ways, you create a construct of a self-reference source of action. Now, there's one thing that's very wonderful about this genesis of self, especially powerful in we humans. And the fact is that it's built for attachments. One of the bases of our being social creatures is that we very generously extend this attachment to the other things around us that in an appropriate emotional context are around us in a powerful or important way. So the mother becomes powerfully attached to the infant, and the infant to the mother. So attached, you could say, so much built into the personhood of the mother, that it is part of the mother. It's part of the mother. Indissoluble. The mother would kill to protect the baby. In a sense, she's protecting herself. The child has an equally strong feeling backward. We extend these attachments out to the people amongst us by virtue of our positive reactions in the appropriate emotional circumstances, and we grow a caring, sympathetic, empathetic individual. We know that there are individuals that grow up amongst us that don't have these advantages. And we can see we can grow a brain just as well. It has absolutely no empathy, no attachment to anyone. We commonly blame them for it. They commonly end up in a prison. They can't live amongst us. It's not their fault. It's usually not their fault. It's usually our fault for being so insensitive and ignorant about the origin of such an ability in a brain, which comes from a plastic brain, only a brain that has the advantages of having a basis of growing attachments to the rest of us. Now, finally, I want to say something else about the growth of each one of you, everyone in this room, and about the person they are, as a consequence of their experiences as a function of your plastic brain. I want to say that it's very bizarre. When you think of how humans were evolved on this planet, you think of how they came into the world as operators in relatively simple environments, relatively simple to manage, primarily trying to stabilize the environments. Our brains were constructed to look for perturbations, things that don't fit with it, things we should worry about, perhaps things that would be a source of opportunity or food. Relatively simple decisions, not really constructed very well to deal with complexity. The way we deal with complex human problems in a modern life are clear and undeniable evidence that we're not good at complexity. Our brains aren't really very good at it. Nonetheless, what do we create? We create complex environments. We pave the world. We cover it with complexity. We modify it radically. And we don't do it just willy-nilly. We do it because in ways in which we're actually trying to control the complexity. Because we know that's, in a sense, that's the only way we can operate within it. Think of it in a simple way. The way we operate obviously controls the way culture has and can evolve. And it's evolving sort of just on the hairy edge of our being able to deal with it, to deal with its complexities. We simplify our environments. I'm looking down here at Washington, D.C., and Baltimore from a satellite. And what I see in red is place where the sun can't strike the earth, where every bit of the surface of what people would walk and move in the landscape is paved. Why paved? Paved so that every footfall is certain, that there can be no surprise, no error. And why would I do such a thing? It's so that I can carry my brain into Never Never Land and worry about the more complex things. We have constructed our environment specifically to disconnect ourselves from reality. And we've done this in an elaborate and continuously complicated way. And we see it occurring now at a tremendous pace. And we, of course, bear a price for this. We don't move across a landscape that doesn't tell us where to go or what's what. And in a sense, we have to do this because it's the only way we can deal with the real complexity of real environments and real worlds. We race around at high speed in several thousand-pound machines on runways. What a bizarre thing. How unnatural this is to move in one of these vehicles. Little wonder that when you learn the skill, you have about a 50% problem of having some kind of disaster as part of the acquisition of the ability. After all, you have to move at 60 or 70 or 80 times the speed that you can move when you're outside or off of one of these machines. And of course, we fill our environments with complex tools, and we spend an incredible amount of our time intensely operating with them at the limitation of the expense of not operating in the physical environment in the way, in a sense, we're constructed to operate and attend. I want to talk a little bit about this a little later when I talk about how we can be stronger later in life. But before I do that, I want to talk about a key aspect of adult cortical plasticity, and that is the fact that the underlying processes that control brain change are reversible. We've studied this in many ways, and we've recorded this reversibility in many ways in studies in animals and humans. And I'm going to try to explain a little bit about what I mean by reversible plasticity. And I'll start by talking about a series of experiments that were led by a brilliant Canadian neurologist who worked with me for several years. Etienne de Villers-Sidani is his name. He's now on the faculty at the Montreal Neurological Institute at McGill University in Montreal. And I'd say that basically the essence of the experiment was to look at rats in the prime of life, when they're the most capable, the most vigorous, in a sense, the most cognitively able, and compare their brains in every way we could think of with the brain of a rat near the end of life. We have a rat that's feeble, that's clearly cognitively impaired, that is expected to die not too far into the future. And we're going to look at the brain every which way we can. We actually looked at sort of 20 major physical and functional aspects of brain function in the prime of life and near the end of life. And the first thing you could ask about this experiment is, well, what is different of these 20 major things? I'm going to tell you exactly what they are. I will in a minute. Between an animal that's really with it, young, vigorous, very sexually active, very mature, very, very effective, versus an animal not so far away, the end of their life on Earth. And the answer is everything's different. Everything's different. Everything we measure is different. The 20 things that we're talking about actually reflect several thousand known cellular and molecular processes. Massively different. Now, the second question we ask is how many of those things that are different advantage the older brain? Anyone want to guess? The answer is simple. None of them. In every way we look at, the older brain is slower, less precise, less accurate, less reliable, less effective, poor at recording information, poor at responding or controlling its attentional resources. Old is not good in an old rat living a boring life. But the most important question is the next question. We sent a few of these older individuals, and we've done many of these experiments in parallel now in humans, to the rehab clinic for special training, asking the question, how many of these characteristics of a brain actually can we change back in a positive direction by retraining the animal? And the answer is simple. We could change everything in a positive and corrective direction. So if, for example, the brain recovered its alertness, we could have the brain actually operate in alerting itself, and we're not just talking about looking at this in a functional way or observing the behavior of the animal, we're actually looking at the neurology of the animal in humans. We've also done these experiments in humans, as if the animal is in the prime of life again. We recover its attention control, recover its accuracy in operations, recover its speed of processing. It's operating with the speed of a young brain again. Its sequencing and predicting powers, its flexibility, its memory, its confidence or its reliability in operations. Everything, all of these dimensions of change that we see degraded as a function of the animal aging in this sense is recovered. Most of them to the level of performance of an animal or near the level of performance of the animal in the prime of life. Now, another really interesting thing happened in the rat experiment, which we have not yet extended to humans. At the end of training, and the training was extensive, at the end of training, the animals were no longer sluggish and no longer obviously cognitively impaired, but were vigorous again. And in fact, this is still an ongoing experiment, their lifespan was extended by about 40% without additional training. The rat had nearly another extra half-life to live as a consequence of being engaged vigorously in training at this point in life. So how do you turn an older or otherwise struggling brain into what appears to be a physically and functionally more capable one? You train it. Of course, you have to train it using certain particular forms. It's not willy-nilly. You have to get to the problems that we knew or we know are the problems that could drive or advantage the brain functionally and physically. Now, we've tried to use this science, again, to understand how we could drive changes in brains, and our primary interest has been in people that are struggling. And you'll see when I talk about the targets of this science in a minute, that our main interest has been the roughly 50% of humankind who have a special neurological burden. We apply that training through using computers, desktop, laptop, or mobile computers, always with training that's adaptive, because that's the form in which we can drive changes most rapidly into largest effect. And what that means is that the training always adjusts to the performance levels of an individual and works on the edge in which the person begins to fail at a behavior, because what we're trying to do invariably is to ratchet the performance level up to a higher level day by day as we engage the brain to drive it in a positive or increasing or more capable direction. Now, we know a lot about the science of brain change. That's been a main thrust of the research in my University of California laboratory over the last 20 years of my research career there. And that has led us, in a massive other body of research from out in the world, to optimize brain training so that we can drive improvements that occurs in the fastest way and is most enduring. The training is almost always targeted to recover behaviors and to renormalize the brain. So we're not just trying to improve your ability to remember, let's say. We're actually trying to improve the memory machinery of the brain at every level so that it's operating with greater functional powers. The training is in almost any real condition is extensive, because if you look at the panoply of changes that occur in a brain that's struggling, an aging brain or any other brain that's struggling for whatever reason, there are almost always multiple systems, multiple functions, multiple dimensions of loss. And the training has to be extensive to get to them. We only apply strategies in the world that are proven to work by trying to conduct gold standard controlled trials. The last thing that we're interested in is actually to apply things out in the world and try to deliver them to people that we have not demonstrated are effective. We can apply it with clinical supervision because we have the great powers of the internet. Everything a person does in training can be recorded. And in many of the conditions that we're interested in, it's important that there be a clinician, a medical doctor, a therapist, other people that are qualified to deal with the greater problems that might apply to that individual who's struggling or impaired. And in that case, we're not going to practice medicine without a license. We have to link that person in and make that person a part of the overall whole and complete treatment of that individual. So we're trying to help that patient, not substitute for what they do. And finally, we've tried to apply strategies that are scalable, that can be applied out in the world relatively inexpensively and easily. We have this marvelous thing out there in the world called the internet. You know how much it costs to deliver software on the internet? Anyone have an idea? Penny an hour. So in relation to almost any way else you think, you could provide help, real help, to people that could advantage them neurologically, that can make them stronger and better and more effective. Nothing can compare with this. This is cheap medicine that can be powerful. I might say that you can see more about this for a consumer at the Posit Science website, brainhq.com. And actually at brainhq.com, you can actually have exercises and get some notion of what it would be to use these exercises for free. You don't have to buy anything. Now, what's different about our approach? Well, we're targeting broader complete brain renormalization, and we're exploiting advanced recording, imaging, and behavioral tools to try to understand what's wrong with the brain and then try to use that understanding to confirm that we've really corrected the brain as well as the behavior. We rigorously apply rules established by neuroscience of brain plasticity. We exploit state-of-the-art program delivery technologies, so this is not just a brain science revolution, it's also a technology revolution. We're trying to work to create medicine, real things that are valid on the level of medicine, not games. Programs are developed and validated by world-class scientists. Every project supported by extensive early discovery and invention. Our approach is validated. It's all about science to the people. We're trying to apply this science to help people with a wide variety of conditions. If I looked at the people in this room, before you reach your 60th birthday, almost every one of you will have had either a history with one of these things, or the person you live with, or the person you love very directly will be captive by the throes of one of these problems. And all of these things are under study, under attack, you could say, by the science that we're applying in our laboratories in California and across the world. I'll talk about this tomorrow in the panel, about what else you should be doing, and just to say what our overall goal is. And it's to extend our creation of this new class of organic, transformative, scientifically validated, and universal accessible training tools to help an individual in need, whether it's from normal aging or from some more serious neurological burden, more effectively use their neuroplasticity to change themselves for the better, and thereby change the world. That's really what it's all about. You have this great resource, every one of you, within your skull. Dr. Gelb made this point to you. I hope you heard it. You have this resource. You have this capacity to change. You have this capacity to be stronger, better, more effective tomorrow than you are today. Celebrate every gain. Use this machine as it's meant to be used to drive yourself in a position where you can grow again if you're not now growing. You are the custodian. You're the caretaker. You're responsible. If you're going to hell, it's your own fault, in a sense. Take responsibility if you can. And try to drive yourself in a corrective, improving, and strengthening direction and make the most of your life. That's my strong and hearty recommendation. Thank you very much.